Good morning. My name is Pani Dekusard. I'm here today presenting for the channel Quantum Origins. The title of the talk today is Time and Eternity. As a reminder, we have created this channel to present the ideas that we published in our book Ways of Nature that was published back in November of 2023. It is a book mainly about biology, and it was supposed to help solve some of the outstanding problems in biology. But what we found out is that to solve those problems, we needed to conjure up ideas and concepts in physics. So we have explored many ideas in physics, and those were published in the chapter 15 of the book. This today gonna be our first physics presentation. We have done some biology presentations already, and it will expand on some of the ideas that was published in the book. So the title is again Time and Energy. We will talk about the essence of those two concepts, the essence of and nature of time and eternity. So what is time? Time here, we will separate it from the compound words of space-time, which was initially introduced by Einstein in the beginning of the 20th century in his theories of special and general relativity. So here we'll talk about time by itself in an isolated manner. So what do we refer to when we talk about time? So let's take a few examples. So if we put new batteries in a new set of batteries in a flashlight, and we turn on that flashlight, so we can ask the question how long the flashlight will shine. So again, a question of time associated with the battery we put in the flashlight. Again, if we fill a lamp with oil and we light the lamp, we can ask the question again, how long the lamp will shine from when we light it to the end, to using up the oil. If we fill a car, like a car tank with gas, we can ask how long that fill tank will last us. Here again, this is my car. After a fill, you see 280 miles. So if we want to make it easier for calculation, we can make it 260 miles. What I'm saying here is that even though it gives us the tank filling mileage, we can put it in time. So it might mean, let's say 260 miles might mean that 6 hours of driving 60 miles an hour on a flat plane. The sun energy, how many billion years before it stops shining from beginning to end. So there's a time component to it. So what we found out is that every time we're talking about time, time is always associated with energy. So time is a feature of energy. So time doesn't have an existence in and of itself. There's no it's a feature of energy. Again, there's no time without energy. Whether we're talking about the flashlight, the lamp, the car with a tank filled with gas, or the sun, we always when we talk about time, duration, it's always in reference to energy. About how long it will take for an energy to reach equilibrium. And most often it's energy, as I said, in search of equilibrium, or energy in motion. So those were specific examples. What about when we talk about time in a general sense? the general concept of time. Let's say today it's May 11th, 2025. Let's say it's 10 o'clock in the morning. So it's what does this time mean? So we feel time always as flowing. Let's say when we talk about when our parents were dating, to our birth, to our adolescence, our adult age, and when we become senior, and our death. So we see the flow of time is the same thing as for the universe. Now we can say that the universe is about 13.8 billion years. It's been 13.8 billion years since the Big Bang, and we can ask ourselves, what does it mean, the general question of time? So we can refer it, we can use it the same way we talked about the flashlight or the lamp. So the general time is associated with the energy of the universe. So time, when we talk about 2025 or 2026, here it's about the flow of time in relation to the energy of the universe. So 13.8 billion years in the history of since the Big Bang. It's 13.8 billion Earth years for our planet. It's 13.8 billion Earth years for any galaxy. So it refers to the journey of the universe toward equilibrium. So it will be the same thing. That 13.8 billion years, we consider 13.8 billion Earth years for any galaxy, whether it's Andromeda galaxy, the Sigur galaxy, Centaurus A galaxy. And for Neptune, which is the farthest planet in our solar system, it takes Neptune about 165 Earth years to make a revolution around the Sun. So we would say that the time from the Big Bang to now for the planet Neptune is 13.8 billion Earth years divided by 165. So we don't use 13.8 billion years in general to refer to the time of the universe. So the general time, we use a more conventional birth of Jesus, which we call the common era, because every time we will not be talking about the year 13.8 billion. So 2025 is just a convention for using a more recent landmark. So what we're saying is that anytime we talk about time, we always refer to energy, and we can define time as a feature that accounts for the entropic state of energy. That's our definition of time. So it refers to the state of entropy of energy, and then we'll talk about specific energy when we talk about the universe. We talk about the energy of the universe that was contained at the beginning, if we can use that word in that sense, in the what we call the Big Bang singularity, that sparked at the beginning, that contained all of the energy of the universe, and from the Big Bang. At the Big Bang, the universe is pure energy concentrated in the smallest of space, the Big Bang singularity. Again, the same thing. If we talk, so this is our concept of time. It doesn't have existence in and of itself. It's always associated with energy, and the general time we talked about is a concept that reflects the state of entropy of the energy of the universe. Measures of time. So we use different measures for time, but the one that's mostly used is the second. Speed of light in meter or kilometer per second, and radiation of frequency in hertz, which is cycles per second. The smallest measure of time is the Planck time. so time is quantized. So there is a unit of time that you cannot go to anything smaller. We cannot cut it any further, which is the Planck time, which is 5.39 seconds by 10 to the minus 44th power. 1 Planck time is a quantum time, so there is no half Planck time. Time and space are linked, and so measures of space mostly is the meter, and we have different other units: kilometer, micrometer, nanometer, and angstrom. Angstrom is 1 meter times 10 to the minus 10 power. Smallest measure of length is the Planck length, which is 1.61 meter times 10 to the minus 35 power. The Planck length is the quantum length. There is no half Planck length like it is for the for time. There is no half Planck time. So time and space are quantized, like it is for light in the photon, which is the quantum of light is the photon. The quantum of space is the Planck Planck space. The quantum the Planck length is the smallest measure of length that we can have. The speed of light, which is 200,000 kilometers per second, or 186,000 miles per second. Speed of light also can be put as 1 Planck length per Planck time. So is time, can time be endless? Because we say that time is associated with energy. Time cannot be endless because energy is not endless. The universe has a certain amount of energy, and it is a closed system, doesn't receive any energy from outside system, nor does give energy to any other system. So the universe is a closed system. If using its energy, it's not going to be endless. So time is not endless, in the sense that if time is flowing and if energy is being used, energy is not endless, but because time is a feature of energy, time will not be endless either. We always consider time as a flow, like those hourglass, time flowing. But what about if we don't switch on the hourglass? Time is contained that is the totality of time. It's the same thing if we fill the car tank with gas and waiting to turn on the key. So here, let's say we eliminate radiation from the gas. We eliminate radiation of evaporation. We'll eliminate those two from the hourglass sign, whatever we put in that hourglass. This is in the context of the universe. We call eternity. In the context of the universe is the totality of time, not flowing yet, but in the context of the universe, we call eternity the totality of time expressed in only one unit of time. That's the further we can go as far as expression of time. We cannot go any further than its expression in one unit of time. 1 unit is not a second, but expressed in the smallest unit of time in 1 Planck time. So eternity is the whole of time. Here we show that the frequency of time, if we express that whole frequency in only one single instant, which is in 1 Planck time. So eternity is the whole of time in a single instant. Again, here the same thing. Again, so the universe singularity, which is an expression of which is a system that from which came the Big Bang. So it's the totality of time that we experience right now expressed in a single instant. So the whole of time in that single instant, if you take a snapshot of it, is the whole of time, which is unmoving. There is no past, there is no future. That whole of time, the totality of time expressed in one single instant, and that's what we refer to as eternity. The whole of time given at once. The Latin word for it is totum simul, all at once. So eternity is the contraction of time in a single unit. We can use some examples to illustrate that. Let's say we have a math class that a student can take over a semester in college. So it's a math class. He has a certain amount of energy, of time he has to spend studying, can spread that over a semester. At the same time, too, that same math class, the student or any other student can take it in a 6-week summer course. Again, that same amount of energy he or she has to spend, it can concentrate it in 6 weeks instead of being on a semester. And you can see some really high-performing students who can take that math class in about 2 weeks. So a contraction of time for the same amount of energy you have to spend, you contract it in smaller and smaller amount of time. That help us understand the concept of eternity. We're going to take one more example. Let's say what about the time it would take you to travel from Maine to Florida. Let's say from the most southern tip of Maine to the most northern tip of Florida. So what is the time it would take you to travel that distance? So we can travel that distance in many ways. We can walk, you can take a horse or a donkey, you can go by car, you can go by the airplane, you can do suborbital travel, or you can do, possibly at some time in the future, we'll be able to do quantum or physical teleportation. So if you have to travel for, again, this is to illustrate the concept of energy expressed in different amount of time. So you can walk from Maine to Florida. That would take you here, according to this map, 25 days, 4 hours. So if you're walking, it take you that long, almost a month. You can go by donkey or horse too. That will take you a bit less time. But if you decide to drive from Maine to Florida, here that map tells us from Maine to Florida, 1 day, 1 hour. So from 25 days, you compress it. You compress the energy you are going to spend by walking to 1 day, 1 hour. So now you can take an airplane. You can fly. The same amount of energy, you can compress it. It can be energy of higher frequency, 3 to 4 hours, depending on which airport you are using. So flying from the most southern tip of Maine to the most northern tip of Florida, from 25 hours to 1 day, 25 days to 1 day, now to 3 to 4 hours by flying. You can do something that in our future, suborbital travel. I'll put that on ChatGPT. It experiments that the suborbital flight from Maine to Florida would take you about 1 hour and 30 minutes. Suborbital flight travel is basically it's a different vehicle. I have some companies that are developing that for tourism, and probably at some point later on faster travel times. There are companies like SpaceX or Blue Origin or Virgin Galactic that are developing those vehicles. It basically takes you from one point. You go, you almost reach orbit. You don't reach orbit, but you cross the boundary between the atmosphere and space. You're in space, get to a short time of weightlessness, and then the vehicle goes up, cross the boundary between atmosphere and space, and gets some weightlessness, and then goes down back to a different point. And then, but as I said, we don't cross into orbit. So it's basically when you cross that line between the Earth atmosphere and outer space, they call it the Kármán line. You cross the Kármán line, so that again can shorten travel distance. So again, the same amount of energy you were to spend, you can again compress it in more and more time, in less and less time. And lastly, it might get to a point where you can do physical teleportation from one place to another one, which is instantaneous. By definition, because of quantum entanglement, quantum teleportation is instantaneous. So it's basically, again, that same amount of energy you are to take to travel from Maine to Florida, you can compress it and compress it with higher and higher energy, frequency energy, to instantaneous, which is the same unit of time, which is basically, as we'll talk about, eternity, which is the plenitude of time, the wholeness of time. You express it in only one unit of time. So that is the definition of eternity. What's called all at once, totum simul. So the passage of time we are experiencing, so eternity is the whole of time in one unit of time, right? The passage of time we're experiencing on Earth is basically the unfolding of eternity. Instead of being one unit of time, can unfold that. So it's like if you were to take the teleportation, you unfold it backwards to suborbital travel, to flight, to driving a car, to riding a donkey, and to walking. So and we're amazed when we look at Plato in the Timaeus back before Christ, more than 2,000 years ago, had great insight to define time as a moving image of eternity. So without even the fancy notions of physical time, he was able to get to that insight that was really amazing. So that's Plato's definition of time, which is a moving image of eternity, which is quite accurate. In summary, time is a feature of energy. So time does not have existence by itself. It accounts for the entropic state of the energy. When we say 1980, 2025, or probably year 2000, so it tells you about the entropic state of the energy of the universe. If you say the universe is 13.8 billion years, if you were to know exactly how long it will take the universe from Big Bang to equilibrium, and how many Earth years it would take you, whenever I give you a year, I gave you, let's say, 13.8 billion years, or 30 billion years, or 45 billion years, that will give you a sense and where the Earth is in its journey to equilibrium. So that's what time is. Time is a feature that accounts for the state of entropy of energy, and eternity is the fullness of time, again given in a single instant. So this was our presentation. We ask you, you can give some likes, so we expect your comments. And if you're interested, we ask you to subscribe to our channels, and we'll be coming up with more topics in physics and biology as well. Thank you.